Okay, they give me hyperbola, and let's rewrite it to standard forms. Your first step, by the way. So I see 16x squared, and then I see minus 25y squared. I see 50y, and I see that's equal to 425. So let's take a look at that. We get 16x squared minus, I'm going to factor out 25 now. That's going to be y squared plus 2y. Oh, no, not plus, right? You got to be careful. Got to erase. Minus 2y is equal to 425. Complete the square, that's plus 1. So I'm actually subtracting 25. So what do you get over here? 16x squared minus 25. And that would be y minus 1 squared equals 400. I'm going to divide both sides by 400. Again, we're trying to aim for standard form. Doesn't look too bad. And the reason for that, 16 goes into 400 25 times. Minus, well, 25 goes into 400 16 times. And 4 divided by 400 is 1. Let me explain that again to you. 16 times 25, I'm claiming it's 400. Let me do that trick I did last time. 25 is 100 divided by 4. 4 goes into 16 4 times, and 4 times 100 is 400. It makes sense, all right? So I got it in standard form. Let's just check the k, and let's see if I did it. Let's see if I got it right. I'm looking at it. X squared over 25 minus y minus 1 over 16. Yeah, looks great. All right, let's keep going. Let's go to the next question. I wonder what that's going to be. And I think it's going to be related to this one over here because it's letter A. Oh, the center. That's fairly easy to do, by the way. The center is going to be 0, 1. That's pretty simple. The vertices, let's go for that. All right, so the vertices. What I'm going to do is set y to be 1. There's going to be 2 vertices, by the way. And what would you get? Plus or minus 5. Let's see if we got that. And we did. Minus 5, 1 and 5, 1. All right, next question is going to be the foci. And I'm going to, maybe draw a little tiny picture of this thing first. Right, so 0, 0 is not 0, 0. What's the center again? 0, 1. And that's up here somewhere. But I know I got asymptotes through that. Let's not be too concerned about what that looks like at this point. But I have my vertices, right? So let's say minus 5, 1's over here somewhere. I'm going to say something like this over here. Again, it's just a really rough picture. We'll look at a better picture later. And I'm going to say, if they're asking for foci, they're over here somewhere. All right? How do I do that? Take the 25, add it to the 16, and that would equal the c squared. 25 and 16 is 41. That's c squared. So the c is going to be root of 41. What I got to do? In from the center, I got to go and root 41. So the foci, well, the y is going to be 1 no matter what I do, right? And you got to move in root 41. So root 41, other direction, minus root 41. And let's see how we did, all right? So, yeah, we got it right over there. We got them both. All right, asymptotes, getting a little better at this. Let's write this down. X squared over 25 is equal to y minus 1 squared over 16. I'm going to rearrange it a little tiny bit. I'm going to write y minus 1 squared is going to be 16 over 25 x squared. So y minus 1 would be plus or minus the square root, use square root rule, 4/5 of an x. Y is equal to plus or minus 4/5 of an x plus 1. And let's see if they have that written down. And they do. It's right over here. All right, a little different order, but still the same thing. It's 1 plus or minus 4/5 of an x. Let's just do the graph of it. My graph over here, really kind of hokey. Let's look at a better graph. And let's just make sure you know the points are. The center, really simple to do. We did that before. That's 0, 1. The vertices were really simple to do. We got that point over there, and that was 5, 1. And the other one, the other vertice, was at minus 5, 1. And the foci, computational, but I did do it. And that was root 41 comma 1, and this foci over here, these are foci, was, what was that? Oh yeah, minus root 41, comma 1, all right? All information we got, this asymptote over here is y equals 4/5 of an x plus 1, and this asymptote over here is y equals minus 4/5 of an x plus 1. And again, just tracing in, roughly speaking, what the hyperbola would look like, all right? Again, the machine does a much better job, all right? Everything's done. Thank you.